Hi there. We are continuing with inverses. We're continuing with inverse functions. For this one, I just want to explain logarithms. Exponents and logarithms, you are going to use them when you are dealing with exponential functions. So we use logarithms when solving for unknown exponents. When your unknown is on the exponents, just like this. I believe you have used it in when you are dealing with number patterns. We have dealt with something like this. Now, solving for a here, this is going to be your a is equal to, we take log of the log of 8 in base 2 there. So a is equal to the log of 8 in base 2, and this is going to be 3. You can verify that 8 raised to, 8 is the same as 2 raised to 3. Then in general, if you have something like x is equal to a raised to y, we are going to meet something like this, where our exponent, our y there is on the exponent. We need to make y the subject of the expression. This is going to be y is equal to, you take log of this value, that is log of x in base a, log of x in base a. Now we use this in determining the inverse function of an exponential function. For example, if f of x is equal to 3 raised to x, our unknown is on the function there. It's on the exponent. The first step to determine the inverse function for this one, write it in terms of y. There we are, and then swap the x and the y. So we have x is equal to 3 raised to y. Now we want to make y the subject of the expression there. So this is going to be y is equal to the log of x in base 3. And there we are. And then that means our inverse for that function is equal to log of x in base 3. That is the inverse for this function. I have another one. I have just 3 examples here. The second one is h of x is equal to 3 raised to negative x. 3 raised to negative x. Alright, the first step, you write it in terms of y, that is y is equal to 3 negative x there, and then swap the x and the y. So you have x is equal to 3 raised to negative y, 3 raised to negative y, and then make y the subject of the expression. If the y is negative there, it should go with this negative, so it's negative y is equal to the log of x in base 3, and then after that you can divide both sides by negative to have y is equal to negative log x base 3. That is my second example there. And then the third example, or the last example, we have g of x is equal to 3 with a negative x there. Alright, I'm repeating an example. Let's do this one. G of x is equal to negative 4 raised to x. You see the difference. The previous example, our negative was on the exponent there, and then now our negative is on the base. So this is y is equal to negative 4 raised to x there. And how do we do that? let's exchange, or let's swap this. We have x is equal to negative 4 raised to y there. X is equal to negative 4 raised to x. And then the next step, take your negative to the other side. Let it be negative x is equal to 4 raised to y. We do not want our base to be negative. So when we have this, we are going to have your y is equal to the log of negative 4 sorry, the log of negative x, in base 4, so this is how we write it. So our inverse then will be the inverse of g of x, that will be is equal to log of negative x in base 4. Basically, this is how we do it. That's all I have for now.